Section 7.2, Boyle's Law. We're going to be looking at a relationship between volume and pressure at constant temperature. Robert Boyle is famous for Boyle's Law. He discovered that the volume of a given gas at constant temperature is inversely proportional to its pressure. So essentially what that means is if you increase the volume of a gas at a given temperature by a factor of 2, the resulting pressure is decreased by a factor of 2. Here's Boyle's Law in action, basically. You have a fixed temperature. That's why we're not looking at changing temperature. It's not noted at all. We also have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these little molecules representing gas molecules. And this gas occupies a total of 8 liters when there is 1 kilogram of force applied to it. So that's, remember, our pressure is force applied over an area. If we double that mass, we go from 1 kilogram to 2 kilograms. Well, now all of a sudden, that same gas at the same fixed temperature, well, this piston gets depressed downward and our volume drops from 8 to 4 liters. Again, double the mass to 4 kilograms, our volume is going to decrease to 2 liters. Okay, so we see that decreasing. We increase our mass, or we double our mass, we cut our volume and decrease our volume by a factor of 2. All right, so that's effectively what we're looking at, how pressure and volume are related to one another. Okay, volume and pressure data for a given sample at a constant temperature. So our volume, 4, 2, 1, and half a liter. The pressure is going to be 1, 2, 4, and 8. The volume times our pressure, our liters times atmospheres, is 4 across the board. Okay, so the product of volume and pressure is a constant. Boyle's law says that basically when you multiply the pressure and the volume, you have a fixed number or a constant K. Okay, and then we also have our inverse volume, which goes up as our pressure goes up. So a graph that represents volume versus pressure, well, it reflects this right here. Whereas when we graph the inverse of the volume versus pressure, we see a linear relationship, a linear increase in that. Now, can you predict changes using Boyle's law? For a given sample, we need to know that our pressure times our volume is K. If you change that sample of gas from one pressure, P sub 1, to another, P sub 2, at constant temperature, the volume will change from V1 to V2. So this is almost very similar to something that we've seen before, and that something is C1 V1 equals C2 V2. Now in both sets of conditions, our pressure times our volume equals the same constant. So we could say P1 times V1 is equal to K, and K is also equal to P2 times V2. Or we could, like I said just a moment ago, drop that K factor and say P1 V1 equals P2 V2. The end. Now a sample here, or a good question, practice question related to Boyle's law would be something like this. A 3.5 liter sample of hydrogen gas. Okay, so let's go ahead and write volume 1. V1 equals 3.50 liters. This is our hydrogen, so I'm going to write H2. Has a pressure, P1, is equal to 0.750 atmospheres. Now we've talked about different pressure units, but let's not worry too much about that because unless it changes, we don't have to worry about it changing. The question is, what is its volume if its pressure is increased to 1.5 atmospheres? So then we've got V2, which is what we don't know. But we have our P2 value, which is 1.50 atmospheres. So we could set this up as 0.750 times 3.50 is equal to, well, V2 times 1.50. And there we go. So I'm going to punch this into my calculator. 3.5 times 0.75 is 2.625 equals 1.50 V2. So divide that by 1.50, and that gives me V sub 2 is equal to 1.75. There we go. All right, another practice problem. A 1.45 liter sample of argon gas, AR, has a pressure, so I'm going to label this as V1 equals 1.45 liters, and P1 equals 0.950 atmospheres. Okay, that means we're going to want a V2 and a P2. What is its volume, that same sample, after our pressure is increased to 787 torr at constant temperature? Now this one, you might look at it and think, oh, this is a little bit tricky. I don't want you to do that. This isn't a particularly tricky question. It's effectively the same question. The only difference is our units have changed. So we have to take that into consideration. So before I write my pressure, I'm going to convert this 787 torr to 760 torr is 1 atmosphere. So 787 divided by 760 is 1.036 atmospheres. So now I'll set this up as 1.45 times 0.950 is equal to V2 times 1.036. So 1.45 times 0.950 divided by 1.036. V2, our answer, which I'm going to switch, and I'm going to write that in green. V2 is 1.329. So I'll change that to 1.33 liters. So that shows that our pressure went up, therefore our volume went down. It went from 1.45 to 1.33. Well, I hope this was helpful. I'll see you in Chapter 7, Part 3. Have a good one.